Illustration number 3 will be utilized to explain the concept of exchangeable cations and where they occur within the mineral structure. To this point in time, we've talked about the tetrahedral sheets and the octahedral sheets. You should be able to recognize that this type of a mineral structure is a 2-to-1 type of mineral. That is, that we have one tetrahedral sheet, an octahedral sheet in the middle, and then another tetrahedral sheet on the outside. It's also illustrated over here where we use the larger cylinders to represent the anions and the small darkened circles to represent the cations. I think you can see that from a diagrammatic or illustrative standpoint, this is a little easier to see. We visualize it this way because I do not want you to get the interpretation that we have a lot of space in here between this cation in the center and this oxygen ion. And indeed, we do not have that space in there. Those oxygens are going to be held together and actually touching each other in as tight of arrangement as possible. That is going to create a very small central cavity so that only certain cations can fit into that cavity. In other words, in this tetrahedral structure I'm diagramming right here with my pointer, the only thing that can fit in there really well is silicon, but aluminum can also fit in there to substitute for that silicon. But it's going to force these oxygens a little further apart when that happens. In the octahedron here in the center, this cavity is larger when we put 6 oxygens together, or whatever number there happen to be based on the degree of oxygen sharing. And that cavity will best accommodate aluminum with its physical size and charge of +3, but it can also accommodate magnesium and, to a lesser extent, calcium in that cavity space. In between one platelet of the mineral and the next platelet of the mineral, we have an interlayer space. That interlayer space is going to be occupied by adsorbed cations, some of which are called exchangeable cations. This term, exchangeable, is implying that they can be trading places with something else. And indeed, that's true. Cations that fit in there could be calcium, could be potassium, sodium, magnesium, etc. Those that fit in there can actually be exchanged or replaced by other cations out here in the solution, the soil solution around the mineral particles in the soil. Exchangeable cations do not only occur in here between the layers, as an interlayer cation between the layers and the platelets of the mineral, but of course they're also found out here because we don't have all of these negative charges on the oxygens, on the outside platelets in these mineral structures occupied. These exchangeable cations can also be held in a loose arrangement out here around the outside of these platelets of the mineral structure, on the surface of the mineral particle itself. So that introduces the term of exchangeable cation. Only certain cations are found in appreciable content in the soil solution. If they're going to be exchangeable cations, meaning that they can go on to these exchange sites on the mineral particles of the soil, they must also be found out here in the solution that surrounds these mineral particles in the soil. We will describe and define for you at a later point in time a more complete explanation of exchangeable cations and which cations can occur on these exchange sites.